Let's take a look at this net present value problem or example, and it uses MACRS depreciation and also includes the sale of equipment. Now the problem appears here. It's a little hard to read. Let me read it to you so at least you can hear it. The Fortune Company is considering a new project which will require an initial investment in fixed assets of $800,000. The net working capital requirement is $120,000 initially, plus an additional $40,000 in year 2. The project has a 4-year life and generates cost savings of $400,000 per year. The tax rate is 35% and the discount rate is 12.5%. The fixed assets will be depreciated using 7-year property MACRS and will be sold for $150,000 at the end of the year. Okay, the MACRS depreciation factors are given, and you see them right here. 0.143, 0.245, 0.175, 0.125, and so on, over 8 years. And we're asked to determine the net present value of this project rounded to the nearest whole number. Now, I'm going to present this one in thousands of dollars, and I'm going to show you how I laid it out. And to save time, I've worked it ahead of time. I put the periods going across. So period 0 means today, and then these are the results is at the end of year 1, the end of year 2, 3, and 4. So we know we have a cash flow expenditure. So I'm showing that as an outflow in parentheses of $800,000 for equipment and $120,000 in the first year, then another $40,000 at the end of year 1. Now the project comes to an end at the year 4, so we get the full $160,000 back of our working capital, and we're going to get cash proceeds of $150 for the equipment at the end of year 4. At least that's what we're estimating right there, $150,000. Okay, there's our $400,000 of cash flow savings. Let me move the mouse off, and I'll just use my arrow key to show you where I'm at. Now, we needed to calculate the depreciation, and I did that down here. I prepared a schedule of depreciation. I dropped in the rates they gave us, and then what I did is I multiplied, let me hit the F2 and you can see, I multiplied the $800,000 of equipment, all this is in thousands now, times the current rate. So that's D28. From there I just copied it across. We multiply the 800,000 times the 2.45 given in cell E, E28, and so forth. Okay? Now at the end of that we are going to need to know the book value, so what I did is I took the equipment, 800,000, less the sum of all the depreciation taken for tax purposes. Okay? And of course we're using MACRS depreciation for tax purposes, so it looks like we'll have $250,000 worth of equipment. I'm sorry, let me say that another way. The book value of the equipment will be worth $250,000 at the end of year 4 when we sell it, and we're going to sell it for $150,000. All right, so that explains where depreciation comes from. Okay, so we have incremental income of $286, $204, $260 before taxes from this project. There's also a loss on the sale of equipment. We'll get to that in a moment. But what that means is the income before taxes is $286. We need to subtract off the taxes because Uncle Sam is going to share in that, not us, to come up with our incremental income after taxes that we will receive. Remember, we're working towards a cash number here. We have $186,000. Then we add back the non-cash expenses, which is the depreciation. And I know you can't read all of that. I probably should abbreviate that. I'll just abbreviate it as depreciation so you can see. So we add back the 114 from above, the 196 in year 2, and so forth. Now, those numbers originally come from here. Okay? And we do that to come up with the net cash flow. Then we need to take everything into consideration. So the first year, we've got the cash flow of the equipment going out the door, the working capital, and nothing else. By the way, this is not the first year. This is at the start of the project. The end of the first year, we knew we were going to spend another $40,000 in working capital. It's from right here. And based on the cost savings less the depreciation, Then we do the tax calculation, then add back the depreciation, because depreciation is a non-cash expense. We can come up with the net cash flow. Now, you actually don't have to subtract the net depreciation and add it back. You could just calculate the tax shield directly, right? Take the 114 minus the tax rate, and you can calculate what that saving is directly. But I like to do it the long way. Okay. Then I simply go through the same calculation of all the cash savings. Now, in the last year, we've got to add the loss on the sale of equipment. It had a book value of $250. We're going to sell it for $150. So there is this loss of $100,000, right? 150 minus G30. Oh, I actually typed in 150. To be correct, I should actually say take G11 minus G30. Okay, so I pull it from above. I'm going to be consistent in how I use Excel. And then I work my way down. So we've got that extra loss to consider. When I'm done, this is the most important line right there. That's my schedule of net cash flow. I drop in 12.5% and compute NPV. Well, how do I compute NPV? I'll hit the N2 and you can see the formula, but why don't I just call up the formula bar? Actually, I'm going to do this in a couple steps here. That's going to change it slightly. That's the wrong answer, but why don't I actually compute it for us? What I normally do is I type equal NPV, hit the left paren, hit the F2 to call up my function arguments, then I go point to them. Okay, so my rate is there, and then my values have to start at the end of the first period. So I've got to start here and go through there. And this is where we get fancy. Now I'm done with NPV, but that's not the NPV because we've got to remember to add in the initial cash outflow. So I add it in right there, and that goes outside the NPV formula. When we do that, we compute an NPV, and I'm going to bold this, of $187,260. Now, this may not match exactly the source of this information, and that may be due to rounding in how the calculations were either done here or whether they used a table approach. Keep in mind, if they're using NPV interest factors, there may be a rounding effect. But this is how I would calculate net present value to this problem.